Appreciate it. Good morning, everybody. My name is Peter Rogers. I am the Warning Coordination Meteorologist here at the National Weather Service in Sioux Falls. And I will be co-presenting this morning with my counterpart just to my north there in Aberdeen, Kelly Serr, who's also the Warning Coordination Meteorologist there. I do want to take a quick moment to recognize our team. This has really been a multi-year project, and it will continue even beyond today for sure. Probably tracing its origins at least back to 2020, maybe even a little bit earlier. But in addition to myself and Kelly, Kevin Deitch, the WCM at the St. Louis office, has been significantly involved, as well as Phil Schumacher, who's the Sioux here in Sioux Falls. That kind of rounds out the Weather Service folks for this particular survey component of the overall project. But then I do want to give a huge shout out to our friends at NCAR, who have been a huge help not only in the development of the survey, but in the analysis and even the visualization of a lot of what we're going to be showing you here today. So like Julie DeMuth, Robert Presley, and Christopher Wirtz, thank you so much. And I think Robert and Chris are on the call today, so if something comes up, they can help out with this as well. So with that, I will get started. So hopefully this works. We do have just a few poll questions that we wanted to try to use to interact with you all today here. So if you have a different browser window or on your phone, if you want to either go to the link there in the top left-hand corner, pollev.com/nationalweat901, or if it's working, you should be able to scan that QR code in the upper right-hand corner as well. But I just wanted to get a quick idea here of who we're talking to today. I know this specific project was a central region effort, but at the same time, I do think that there are some others from across the country who are joining us as well today. So just give us 30 seconds or so here to let people throw their location in there today, and we can get an idea of where everybody's coming from. And I'm seeing the dots, so it's working, so it's good to see. A lot of folks from Western region so far. All right, we'll just get a couple more seconds here. Western region, you're representing today. Thanks for all being on today. A little early for some of you as well, so I really appreciate that. All right. Very good. We'll continue on here for time's sake. And you can just leave that link open for the rest of the presentation. We'll have a few more questions to ask throughout the rest of the slides here. So just a really quick outline here. Like I said, Kelly and I are going to be tag teaming this. I'm going to provide some background, some of the survey overview information, how it broke down in terms of numbers and geographic distribution. But the majority of this talk is going to be focusing on some of the key findings that we had, and then we'll summarize it here at the end. So just to start with the background here historically, so we're talking certainly the past couple of decades within the Weather Service, when we provide snowfall forecasts, it's generally been either a single number or a narrow snowfall range. On the right-hand side here, you see a sample image of what we would consider a legacy forecast for snowfall ranges, where they're pretty narrow, 4 to 6, 1 to 2, 8 to 12, 2, 3, 4 inches, and that's about it. But as we all know, with the advancement of technology, and especially the ensemble modeling systems that we now have available to us, we have a lot of probabilistic information that we can include, and that includes snowfall forecast information. That can be shared in many, many different ways. The question always has to be asked when you have these new services is, yes, we can do it, but should we? And so specifically with regards to our partners, we need to ask, are probabilistic messages understood, helpful, and actionable to partners? And again, for this talk, we're focusing in just on snow forecasts, but those are the types of questions that we're wanting to know, or the types of answers we want to know. So like I said, this goes back several years, all the way back to the winter of 2020-2021, when there were 9 central region offices that participated in a probabilistic messaging test bed. You can see the offices there on the right-hand side that participated. Several objectives with that particular test bed: to determine the most effective messaging strategies in advance of winter precipitation events, to investigate efficient and effective ways to collaborate messaging winter precipitation information utilizing probabilistic intelligence, to determine the most effective ways to resolve inter-office messaging inconsistencies. And these 3 goals were more or less met during the actual test bed during that winter season. But the one goal that was not met at the time was this last one highlighted in red: assess partner comprehension of probabilistic forecast messaging. But in order to do that, we had to have a method of doing that, and that's where this survey came into play. one of the big findings from the internal test bed back from 2020 to into 2021 is that some forecasters have concern about how well weather service partners understand probabilistic information and how it's being used. So this map here on the right-hand side, you're going to see this come up multiple different times here throughout the talk, but this is just an example of a dynamic snowfall range forecast based on the 25th and 75th percentiles for snow. This is across the state of Iowa, and you can see that there's some fairly large ranges on here. For example, Carroll, 1 to 7 inches, Marshalltown, 3 to 10, Des Moines, 7 to 13, some pretty big ranges. So this is definitely different from the standard legacy smaller ranges that I showed you a few slides ago. And so from that test bed back in 2020, 2021, some forecasters felt these 25th, 75th snowfall percentile ranges were too large and would result in a negative impact with the public and have little value to decision makers. So that was one of the things we wanted to really dive into with the survey is that perception internally within the Weather Service, what partners actually think when we have this kind of information available. So we had to do the survey. The survey goal is to evaluate partners' thoughts and opinions about winter weather forecasts that we provide, including probabilistic information. Now, this particular survey, we really focused on 3 core partner groups. Now, when we put it out, we sent it out to our full partner lists, but really from the analysis and from this point forward, the information we're going to share with you is with regards to emergency managers, school officials, and that's primarily school superintendents, but not exclusively superintendents, and then transportation officials. Now, obviously, we work with a lot of different partner groups that go well beyond these core 3, but we do know that in the winter months, these 3 partner groups are routinely using our information to make some critical decisions for their particular operations. Because of the scope of this survey, it did require approval from OMB, and so that process took quite a while, but we did finally get that approval a while back. And so for those who are interested, the control numbers there on the screen. So what did this survey actually look like? It was large. It took a while. It was 30 questions, and they weren't simple questions. They were distributed by all 38 Central Region offices from May 31st to July 12th of last year, 2022. And you could say, well, that's kind of a strange time to be putting out a survey about winter weather. And I agree with you. It was not our intention. We were trying to do it a little earlier towards the end of that winter season. A few things caused us to have some delays, but we did get it out, and we still had a very good response, as you'll see here soon. Some of the questions that we asked: job roles and decision thresholds, preferences and uses of winter forecast information, probabilistic information, interpretations, uses, and preferences regarding snowfall probability of exceedance graphics, snowfall range graphics, and then use of probabilistic snowfall timing graphics. So a lot of different things here over the course of those 30 questions. So how did it break down here? So we had just shy of 3,700 people that started the survey, and then out of those roughly 3,700, about 2,500 actually completed the full 30 question set. Talking with our friends at NCAR, this is actually a very good result. The fact that we had almost a 68% completion rate, especially again considering how long it was and how complex it was. When you look at how it broke down amongst some different categories here, again, those 3 core partner groups that I talked about earlier, emergency managers consisted of 37% of the respondents, school officials 22%, transportation 10%, and then we have this kind of catch-all other category, which was almost a third of the respondents. So the other category could have been broadcast media, healthcare folks, law enforcement, fire, and so on. We're going to include that other category in some of the graphics we show throughout this talk. However, we're not going to be explicitly talking about what to do with that. That will require future analysis. We really focused on these core 3 for this particular part in the project. Looking at the educational breakdown, the majority of folks actually had a bachelor's or a graduate degree, and then on the gender side, the vast majority that responded were men. Looking at the geographic distribution, like I said, this was distributed by all Central Region offices. Probably does not surprise anyone that some of our highest response rates came from some of our larger geographic areas. So St. Louis topped out at 195 responses, Chicago at 171, Des Moines 162, and then kind of fell off below that, but still very good distribution across the region. We were happy with these results. So from that first question I asked, I saw a lot of you were from Western region, saw a couple Southern region folks popping in there as well. Again, thank you. we don't have the time to go through all 30 questions on this talk today. So if you are really interested in the full report that shows the breakdown of all 30 questions, you can either go to this link here or scan the QR code. You do have to be in the NOAA ecosystem in order to access this, but I encourage you to check that out if you haven't done so already. I know that the Central Region folks have probably seen that already. And then on the right-hand side here, this is a great tool that was put together by the folks at NCAR. Special thanks to them. This is a visualization tool that allows you to kind of slice and dice the results the way you want. So today, we're going to be focusing on all of Central Region, but with this tool, you could drill down to one specific forecast office or a couple different forecast offices, and you don't have to be under your NOAA account to access this if you click on that link or on that QR code. But if there's questions specifically about this tool, either Chris or Robert should hopefully be able to answer those at the end here. All right. One little point of clarification here before we start diving into the findings is this question of when do we know enough? So 30 questions, complex questions, a lot of information to sift through. And it can be challenging to decide when do we know enough to warrant shifts in operational practice. Our goal is to try to come up with some best practices based on this survey information. The thing we did not want to do is that we did not want to have unintended negative consequences. Say, okay, well, the answer to this question is telling us this, therefore we should do that. But then maybe that actually pushes things in a different direction so that partners are making worse decisions because we made that shift in operational practice. So we were very careful in the recommendations we have made. We did have some differing ideas within our team, but we largely aligned in our thinking. And one thing that became abundantly clear is that as we continue to go through the survey results, additional research is definitely going to be needed in some areas to figure out exactly what the partners are telling us with regards to some of this probabilistic information. All right, so before I show you the findings, here's our next question. If you still have that up there, I'm just curious, and this is kind of a gut feel type question, but what is your level of comfort in including probabilistic information specifically for snow forecasts? Maybe you've done it a lot, maybe you haven't done it at all. So I'm just curious where people are at here before we get too far into the details. And maybe as a attendee on this webinar, you've already been familiar with the topic and you're very comfortable. It looks like the vast majority, I shouldn't say vast, 60%, 55, 60%, very comfortable. Other people are comfortable. For the 7% or so that are not comfortable, welcome. I'm glad you're part of this. I hope this is helpful for you as we go through some of these results and builds that level of confidence and comfortability with using some of this information. All right, so first finding, aim to further build relationships. Okay, so I know this seems kind of intuitive at face value, like, what do you mean all that survey information for building relationships? I mean, that's what we do every day, right? Okay, well, let's actually dig into this a little bit. So we asked the question, imagine that you work in your current job role in Marshalltown. So here's that map I showed you earlier. We're going to bring it up again and again. And in this instance, we're focusing in on Marshalltown, highlighted in white there with that 3 to 10 inch snowfall. And so we asked the partners, if you were to get a forecast like this, how likely would you be to do the following? Monitor the Weather Service for updated information, prepare for the storm, contact my local Weather Service office so I can talk with someone, seek a forecast from someone other than the Weather Service who could give me more certain information. And this is how it broke down. So I'm going to be showing lots of charts and graphs today here. But what we have are the different color bars are representing the different partner groups, emergency manager in blue, school officials in red, transportation officials in green. Now, these are the mean responses for each partner group, so keep that in mind. But on the y-axis, we have not at all likely up to extremely likely. And then on the x-axis there, we have the different actions from prepare for this storm to contact my local weather service. So you can see there, for preparing for the storm and monitoring updated information from us, very high responses, very likely to approaching extremely likely in some cases. So very good responses. When you look there at the second action item, there's seek a forecast from someone other than the Weather Service, lower overall, but transportation officials stick out there a little bit higher as somewhat likely, or a little higher than somewhat likely in the means to seek out a different forecast. And this question did not ask why. We may have a little bit of a general idea of why that might be the case. I know at least for states that participate in Pathfinder programs like Minnesota, they partner with a third-party private forecasting firm. in addition to the weather service. And so maybe that's where some of those types of responses came into play. But school officials are not too far behind transportation folks as well. So again, we don't know why, but why would schools be reaching out to others? Is it because they don't have the information they need, they don't understand the information they're getting, or they're just wanting a second opinion? On the far right-hand side, they're contacting the local weather service office. So this is kind of that idea again of building the relationships. So the responses are a little on the low side. Emergency managers are highest, which I think makes sense for a lot of our offices because they're kind of our go-to person every time there's something going on. But for schools and transportation, it's lower. And so does this present a possible opportunity for additional or renewed IDSS? Maybe through a formal IWT, when you're meeting with partners, you can ask them like, hey, notice we're not getting a lot of phone calls. Is it because you don't need to? Is it because you don't have time? Is it because you don't understand things? So to try to parse that out a little bit and find out, like, are we getting the information that you need? And is it in a way that you can understand and take action on? So just some different things to keep in mind when we're looking at this pretty top level question. All right, next finding. Partner tolerance for timing, uncertainty, and lead time can guide messaging. All right. A lot of graphs here again. We'll try to make sense of them. So here's a question that we asked. At the lead times listed, so lead times were less than 24, 24 to 48, 48 to 72, and greater than 72 hours. How certain the forecasters need to be that there could be a high impact winter storm in the area where you work for you to start taking actions listed. Now, this particular graph is only showing you transportation officials, and we have these for other partner groups as well, but the responses were pretty much similar, so we're only focusing on transportation here. But we gave them a possible list of actions. In this case, for transportation, it was planning for road treatment and plowing or securing extra staff, resources, and material. And we asked them this question. And so the darker blues there are the longer lead times, the lighter blues are the shorter lead times. As you can see, partners have a higher tolerance for more uncertainty at longer lead times. Okay, by the nature of our forecast and predictability, this kind of matches, but greater than 72 hours for transportation officials, we're actually a little bit below 30%. That grows to more than 50%, approaching 60, 70% once you're within 24 hours. But it shows that, again, they have that higher tolerance. There is a caveat to this, though. We don't know the critical lead times at which partners need to take that action, so no less than a certain number of hours to have time to do what's needed. One thing, now this question didn't specifically deal with any of the products we issue, but one of the things that I find interesting here is that normally when we're issuing winter storm watches, winter storm warnings, for watches, we want that 50% higher chance of occurrence. For warning, 80% chance or higher occurrence. And so when you look at this, normally when we're issuing watches, it's in that 24 to 48, in some cases beyond 48 hours, but from a partner response rate here, we're looking at in that 30 to 50% range. So it's actually, right around how we define, a watch issuance versus even a little bit less there towards the longer lead time. So just something to keep in mind. And it seems to match up rather well with how we operate right now when it comes to those headline products. All right, so then we switch gears here a little bit. We gave them a series of different forecast elements, and we said, please rank these elements in order from most to least important. So again, emergency manager in blue, school official in red, green transportation. Again, these are the mean responses for each partner group, going from least important at the bottom to most important at the top, and then the different options there on the bottom, the x-axis. Chance of snow, amount of snow, timing of snow, including start and end times, timing of snow, considering rate information, and then areas that will get snow. And there's variations here again. Consistently, we have timing of snow when we're talking about rates as the lowest or the least important. And then for most important, most consistently, either we're getting towards that areas that will get snow, even timing of snow a little bit. But then when you really start to break it down again between different partner groups, you can see that transportation officials, that timing information races to the top. For emergency managers, the amount of snow is higher than other groups. And so it's a challenge, right? Because when we're dealing with messaging, it's not just when do we get information out, but what different elements are we putting out at different times, and are they being used by different groups in different ways? And so it's just important to know those differences as much as possible when we're dealing with our different partner groups. Okay, let's take it one step farther here. So partners need different elements at different lead times. So now we asked, how many hours before snow begins do we need forecasts of these elements in order to make your critical job decisions? The options we gave here are slightly different than the previous slide, but they're pretty close. In this case, we're talking snowfall amount, snowfall start time, end time, rate, and location. And this is a stacked bar graph, and this is for all responses. So this isn't broken down by partners here, but it's the percent of respondents that responded for the longer lead times, which again are the darker colors, and then the lesser lead times, which are the lighter blue colors. And so you can see there at the top, location, more than 50% of the overall respondents said that we want that information beyond 24 hours, which are the darker colors in the blue. When you get to amount, it starts to fall off a little bit. And then when you get into the finer details like start time, rate, end time, then they're saying, hey, you know what? In a lot of cases, we don't need that until we're within 0 to 12 or 12 to 24 hours. Now, there's not to say that there's still a sizable percentage there on the higher end, but you can see how things trend as you go from longer lead times to shorter lead times, as well as the different, the level of detail that they're asking for. And in some way, intuitively, I think this makes sense, especially when you're looking at location there on the top, because it's probably a series of questions going on in the partner's mind. It's like, okay, first of all, where is the snow going to fall? If it's not going to impact me, then I don't really care about the rest of this. So I first want to know where it's going to fall. And then if I know it's going to fall in my area, okay, let's start talking about amount and timing and rate information. And so that could be one possible explanation as to how these results panned out. Okay, next question here for you before I try to combine this into a more meaningful graphic here for you. Does your office routinely incorporate a messaging funnel in operations? And I'll try to better define what I mean by messaging funnel on the next slide. And if you don't know, which it looks like several of you don't, that's okay. But just leave this going for a couple seconds, let people respond. Okay. So roughly a quarter say yes, a little less than 20% no, and then a lot of you say you're not sure what a messaging funnel is. So let's talk about that. So kudos to Robert at NCAR for putting this together. Fantastic. Robert, if you're on, thank you so much. So what this is attempting to do here is to combine the results from the previous two slides that I was showing as it related to lead time information and the importance of forecast elements. And so I'm going to try to take a little bit of time here to explain this so we can all get on the same page here. But you have three different polygons representing three different partner groups: emergency managers on the left, schools in the middle, transportation on the right. Then on the y-axis there, from bottom to top, you have lead time, 0 to 12, 12 to 24, and so on. Now, the shading of the actual words is the forecast element rank. So the darker colors mean that that was more important to that particular partner group. And then the size of the word means the percentage of the participants who want that element within that specific time range, that specific lead time, okay? And so in general, there are likely effects that are conditional for partners, perceived and inferred uncertainty at longer lead times, which correlate to predictability. But in general, there is this messaging funnel need that goes from kind of location to amount to timing to start and end time to eventually rate. And when you look at this, you can see, and when you're in that 48 to 72 hour time frame, the words are small, they're not very dark. And so, certainly we can start talking about information at that time, and we do, but it really changes significantly once you get into 24 to 48 and then 12 to 24 hour, where you're starting to see amounts, start time, end time increase in importance with the darker blue colors, as well as the number of people who want that information in that time frame for the size of those words. And so just look at schools, for example, and schools tended to pop out a little bit more than others because their decision timeline is different from others, but 12 to 24 hours, that's really when the majority of them need that start and end time information, the location and amounts. And as you can see, as you get in that 0 to 12 hour time frame, by that time frame, maybe a lot of decisions are being made already, and so things fall off a little bit. You can see a similar trend there in the transportation officials, where you have start and time amounts and location, that 12 to 24 hour, but maybe even a little more so in the 24 to 48. So when we are talking about a messaging funnel, it's this idea of, at what time do you start talking about a winter storm? At what time do you start to introduce new forecast elements? You're not going to be talking about timing information beyond 72 hours, A, because we just don't know it, but B, because that's not really what they're looking for. So you're going to be starting with, again, and it's generalized, but you start with amount, or excuse me, you start with location. Am I going to get snow, am I not? Then you move down to amount, then you move to timing, then you eventually get to rate information. And so it's this idea, it's expanding the idea of the forecast funnel, going from the synoptic to the micro scale, and taking it to a messaging standpoint where you say, okay, when do I introduce different things at different times? And it's a challenge because it's not only within a shift, but it's consistency from shift to shift to shift within your office, and then also the collaborative aspect from office to office to office. If we're going to be presenting this information at state level meetings, we want to make sure that the office is involved or on the same page when it comes to messaging. And if one office is doing one thing, another is doing another, that can create some challenges and confusion. So this is a great graphic, and I hope it's useful for you, and we can talk more about that later if we need to, if there's questions. All right, Kelly, it is all yours.
All right, thanks, Peter. I am going to take you through a few more findings here from our survey information. So we will carry on. Another finding from the information we gathered from the survey is that timing information is needed and useful to our partners. And again, this might not be anything super crazy. We kind of know that in general, but we have significant data from the survey saying this is useful. So our finding is that if we can develop better ways to display timing information, it would have immediate and favorable impacts on our partners. So on the next slide, you'll see a timing graphic, and Peter, yep, there we go. Peter's got to run the slideshow for me. You'll see a timing graphic. We had several questions relating to this particular timing graphic. I won't go through them all with you here in this presentation, so you definitely want to go out and reference the report. But also intermixed throughout the survey, there were other questions that related back to timing. So lots of useful information. But this particular graphic was a timing graphic, and we asked the respondents if they were located in the city of Sioux Falls, which is in the white box you see on the graphic, and they got this information, how useful would this type of forecast be to you? And so when we asked that question, the responses are on the next slide. Partners overwhelmingly responded that this information is very or extremely useful. Really, somewhat very or extremely useful was 90%, 90+% of all respondents. Again, this is one question. We asked several more like this, but over and over again, we saw that partners want explicit forecast timing information. However, the graphic you saw on the last side was one that was made with a lot of hand editing. They're not quick to produce. We know this as weather service forecasters, that timing graphics can be some of the most difficult and time consuming to create. And so we really want to kind of stress that a focus on these timing graphics, as well as what type of timing graphics are most useful to our partners. Is it a plan view graphic? Is it something that's in more of a chart form? How do we incorporate the probabilistic part of timing, like earliest potential start time, latest potential start time? We don't quite have the tools yet we need to do this, but the survey does show us very clearly that this is something that would be very helpful to our partners. So the next finding, I'm kind of going to tease you with here. The next finding I'm going to talk about has to do with the large snowfall ranges and upper snowfall bounds. And this was the big question. Peter said this in the introduction. A lot of people really had this in the back of their mind, is this large snowfall range useful? I myself had this exact same question. So we posed the graphic that you see here, that you saw earlier in the presentation, and we had them focus in on Marshalltown, which is the white square you see, and we gave them a really large range, 3 to 10 inches, and we picked this range because we were hoping that for all of these users, it was crossing some sort of threshold, so that it made it a bit uncomfortable. And then we asked them, if you got this forecast of 3 to 10 inches, how useful would this be to you? And so before I get into the findings of this, we're going to pose this to you guys in the poll everywhere question. How do you think they answered? If you were a core partner and you would have been asked this question: how do you think the core partners, not how you're answering, but how do you think the core partners thought this information was? Was it useful to them or not useful? All right, you guys are sticking middle of the road there with the somewhat useful is the favored response right now. But I see kind of on a few think not useful at all, and some think it might be very useful. So we'll go to the next slide here, Peter. The finding that we found with the survey information is that the large ranges are found to be useful by our partners, as well as upper snowfall bounds. There is a caveat here, and we're going to talk about kind of some of these unknowns with this information. But when we asked the questions that we did, the answers showed it to be useful. So the question I just posed to you guys, here is the results and how they fell out. Over 55% of all people in all groups said the snowfall range was very or extremely useful. And over 90% of all people in all groups said that it was somewhat very or extremely useful. In fact, less than 8% said that it was not at all or not very useful. So they were finding utility even in this very large snowfall range. On the next slide, we asked them a follow-up question. So they're still in Marshalltown, and they still have this 3 to 10 inch forecast. And then we asked them, what are you going to prepare for? If you got 3 to 10 inches and that's the forecast you were given, what are you preparing for? A majority of respondents said that they would prepare for the midpoint amount, about 6 to 7 inches, although you see the schools stand out a little bit there again. They were even higher, almost nearly 75% said they were going to be preparing for that midpoint amount. But then over a quarter respondents in the transportation and emergency manager officials said they're actually preparing for the high end amount of 10 inches. Less or so on the school side of things, and the schools also were more likely, not a huge contingent, but they were more likely to respond that they 12% of them would prepare for the 3 inch amount, given a large range like that. On the next slide, we then asked, if you got this which of these 3 scenarios would be most problematic for your work operations? You got a 3 to 10 inch snowfall forecast, and the snow actually fell within that range. Is that problematic? Or we gave you a small 3 to 5 inch snowfall forecast, but the actual snow amount ended up being 10 inches. Is that problematic? Or we gave you the high end of 6 to 10 inch snowfall forecast, but the actual snow amounts ended up being 3 inches or less. Overwhelmingly, the respondents said the most problematic situation is having a small range and the actual snowfall amount falls on the high end, kind of toward your worst case scenario of 10 inches. So that's what 60 to 80% of the respondents said in this particular answer. Although the schools, again, you will see nearly a quarter of them did say it would be problematic for them to have a 6 to 10 inch forecast with the actual amount being 3 inches or less. And we had lots of discussion about this, lots of theories. We'd have to actually ask them at IWTs or when we're working with them why this might be. But certainly our theory is that, school officials, they're canceling school, there's canceling events. And if it doesn't pan out, who do they hear from? A whole lot of parents on the back end that are coming after them. So definitely some interesting user group differences with these questions. So on the next slide, even though they're responding that the snowfall ranges are useful, they're responding that the upper bounds are important because they don't want to get caught behind. They don't want it to end up being higher than what's expected, because that probably ends up meaning different decision making for them that they might not have been planning for. But because of our limitations of a survey, we only asked about a 3 to 10 inch snowfall range. We don't know if we had an equally large range that started with 0, for instance. So what if you had a 0 to 7 inch snowfall range? Would the answers be the same? Would we get the same type of results? Because 0 certainly elicits a whole nother, it might not happen at all. So we don't know the answers to that questions. We wish we could have put about 100 different questions in the survey that we could get these answers to, but we just don't have time. We also are just asking for, really a snapshot. Here's your forecast. Is this helpful? We're not showing it evolving over time, which forecast information does. What if the ranges happen to get wider or more narrow? How does this change their perception? Is it still useful information? We don't have the answers to those questions. And so we want to make sure that people keep that in the back of their mind as you are using this information. The next finding revolved around probability of exceedance maps. So users did find probability of exceedance maps useful. However, we're going to really dig into this. Do not expect your partners to be able to deduce information not displayed on a probability of exceedance map. I'll tell you why that is here in a second. So the maps that we gave, several questions, and again, I'm not going through them all here in this presentation, so check out the report and you'll be able to see all the questions relating to probability of exceedance. But we gave them a graphic that looked like this. This particular graphic has the potential for 2 inches or more of snow, and then the corresponding 4 inches or more of snow on the left and right hand sides. There's also text on the graphic, and we did ask them to kind of look at the text as well, the what is possible, when will it happen, what should you do, and really analyze this graphic and describe to us how useful this is to them. So on the next slide here, you will see that timing theme pops out at us again. Actually, the most useful thing for most user groups in this particular graphic is the when will it happen text box. Again, timing is very important. But you also see a large number of respondents found both the potential for greater than 4 inches of snow and potential for greater than 2 inches of snow. Those probability of exceedance maps were very over, 70% there were saying very or extremely useful, and a large majority somewhat very or extremely useful in this particular graphic. We also asked questions about how they would use it in their job roles, not displayed here, but overwhelmingly they thought this information was useful. The next question we asked, there were 2 questions in the whole survey that had right or wrong answers. And these are the 2 questions. There was a right answer for the next 2 questions. So we asked them, with the cities, we have 4 different boxes, white boxes on the map here. And we said, look at these different cities and tell us which one has the greatest potential for getting 2 inches or more of snow. So this required them to actually look at the map and look at the percentages. And if they did that correctly, they would be able to see that Redwood Falls was the correct answer, that had the greatest chance of receiving 2 inches or more of snow. We then followed up with another question. This time they're just focusing on one city, the one in the white box there, Vermilion, and we said, what do you think the potential for 1 inch of snow is in Vermilion? Now, we don't have a prob exceedance map here for 1 inch or more of snow. We only have 2 and 4. So that required them to kind of really think about what these numbers are telling them. And so if they looked and they saw the potential for greater than 2 inches of snow in Vermilion was 48%, then the potential for 1 inch of snow would have to be some percentage that is greater than 48%. So on the next slide, you will see the results of both of these questions. The graph on the left-hand side was the initial question when we asked them to pick out which city has the greatest potential for 2 inches or more of snow. They aced the tests on this one, 90% of them, that's an A, could answer correctly Redwood Falls. But when we asked them to deduce information that was not being displayed on the probability of exceedance maps, approximately half of them could not do that. So that raised a whole lot of questions for us about what this really means. So on the next slide, we do pose this. Although partners say that they find probability of exceedance useful and that they describe the ways they're going to use it, you can read through that in the report. they really struggle to deduce information that is not explicitly on the map. And so the questions that raise for us is, do we need to point them to a tool where they can pick their specific threshold and they can be given the probability so they don't have to deduce it on their own? Or is there some fundamental misunderstanding of probability exceedance graphics that we really need to get questions to make sure that this isn't detrimental in some way by showing these maps to partners? All right, and then the final finding is not exactly an operational finding per se, but in the survey we did find that qualitative versus quantitative expressions of probability shift partner perception. But again, there's a star and it says more research is needed to determine operational implications from this information. So we started by asking a snowfall range question using qualitative confidence wording. So they were given 3 different scenarios. The first one was the National Weather Service could provide a forecast of 2 to 8 inches of snow, which is wide, but it has a high chance of capturing the actual amount of snow that will fall. Or the National Weather Service could provide a forecast of 3 to 7 inches of snow, which is a middle range, but it has a medium chance of capturing the actual amount of snow. Or they could provide a 4 to 6 inch range, which is more narrow, but it has a low chance of actually capturing the amount of snow that might fall. So when posed with these 3 options, a majority of respondents, 55%, preferred the middle range, 3 to 7 inches, with having a medium chance of that actually capturing the snowfall amount. Then overall, 30% responded the wide range 2 to 8 inches with a high chance of capturing the actual amount, and then a smaller contingent picked the narrow range with the low chance of capturing actual amount. On the next slide, we asked this question, but now we used quantitative confidence wording. So now we said, we can give this to you in a different way. And here are the different options. We could say there's an 80% chance of 2 to 8 inches of snowfall occurring, or a 50% chance of 3 to 7 inches, or a 30% chance of 4 to 6 inches. We also told them that we could provide a narrow range of 4 to 6 inches and also include the high end and low end amounts of 2 to 8 inches. So when we posed the question this way, partners' perception shifted quite significantly in some cases. Now overall, respondents said, 39% said they would prefer the 80% chance of 2 to 8 inches. 36% overall said they would prefer to have the smaller range, but they really want to know that low end and high end amount as well. And now only 22% said the 50% chance of 3 to 7 inches. So we broke this down even further from how respondents initially responded with the qualitative wording question, and then how their perception shifted when we introduced those quantitative percent chances into the question. So initially, of the 740 respondents who said they preferred the 2 to 8 inch wide snowfall range, with a high chance of capturing the actual snowfall that's going to occur, of those responses, most of them continued on when we introduced the quantitative wording, and they said they would still prefer 80% chance of 2 to 8 inches. Although there was a small contingent that did drop down and say, well, if you're going to give me everything, I just as soon see everything. Give me a small range, and I want to know that low and high end amount. If you look at the respondents, the majority of respondents who initially said, we had 1,354 respondents who initially said the middle range with a medium chance of it capturing the actual snowfall amounts. They almost split their answers into thirds when we included the quantitative information. So nearly a third then changed their perception and their answers and said they would prefer the 80% chance of 2 to 8 inches. Slightly less than a third said they would stick with the 50% chance of 3 to 7 inches. And then it was roughly 37% that changed the response and said, well, I'd like to know both a smaller range and a low and a high end amount. And then lastly, the small contingent, the 4 to 6, the 388 respondents that said they preferred the very small range, but even though it might have a low chance of occurring, they almost overwhelmingly said, but even though we still want that small range, we like to see the low end and high end amounts. A majority of them said information is still very useful to them. And then smaller contingents went to the different answers that you can see there as well. So we have a lot of questions arise of, why the perception changes so much, especially with that middle group. Is it something about the medium wording that we used initially, that once you start putting the percent chance, that really means something different to them? And we really would like to dig into this further as we go along with future surveys. And so a lot of questions revolving, which one is more useful, quantitative versus qualitative. Obviously, perception's changing, for sure. That is very clear. We also want to know if those goalposts are most useful. You notice in the first question, we didn't ask the goalpost question. And in hindsight, we wish we had, so we could compare that equally. In future surveys, we certainly will do that. But it's another question we have and we want to get more information to. And then also, we aren't changing the snowfall ranges here. Again, this is very static. It's a snapshot on time. We don't know how perceptions might change if we have changing snowfall ranges, if they're widening, if they're narrowing over time. And what if that range includes 0? We did not test that at all in the survey. So just to conclude, some lessons learned from the survey that we have shared to you in this presentation. Still room to build further relationships. Know your partners. Find out their thresholds when they need to know information. Schools really stood out to us as using the information differently, at least compared to EMs and transportation officials, although transportation officials also had some variations as well. Partner tolerance for timing, uncertainty, and lead time can guide that messaging. Those messaging funnels were shown fairly clearly, but also different user groups certainly have different preferences for when and how they get that information. Timing information is very important to our partners, and focusing on ways to display that information quickly with probabilistic data certainly should be a focus of our time and efforts to be able to meet our partners' needs. Upper snowfall bounds and large ranges were found to be useful. But keep in mind, we only tested one range here, and we don't have any data for different types of ranges or if they are changing throughout time. Probability of exceedance is useful, and the users did describe to us how they would use it. However, keep in mind, deducing information not explicitly stated on the probability of exceedance maps was difficult for partners to do. And then that qualitative versus quantitative wording shifted the perception of the users. The responses changed in some cases quite significantly. And there's other research and literature out there that also supports this particular question. So hopefully that information gave you a good, useful data that you can use. Peter does have, we do have a poll question here. Maybe you can just tell us if this information that we provided you today, does that give you more confidence in using this probabilistic information in your winter forecasts? Was it useful and helpful? And there is no wrong answer. There is no wrong answer here. That's what we said in the survey too, our survey participants. There was no wrong answer when you answer these questions. We want to know how you felt about it. And great to see that this information is helping people have a little more confidence when we go out and use this probabilistic data. So that's great to see. And maybe a lot of you were already using it. And so this just reinforces what you are currently doing. So just to wrap it up here, Peter already gave a shout out to everybody we need to thank, but we cannot thank our NCAR partners enough, Julie, Robert, Chris, Robert and Chris, I do believe, are on this presentation. If you have some questions, they can help answer. And then, of course, our National Weather Service team who helped put this together, the Northern Plains WCMs who helped us review questions and select questions for the survey, then Keita Brown at National Weather Service headquarters who helped us navigate the bear that is the OMB survey process. Could not have done that without her. All of the WCMs who asked the favor of their partners to take the survey. And then, of course, the partners who did take the time to respond to the survey. So with that, I think we might have a few questions here, or a little bit of time here for a few questions if anybody does have some. I haven't been following the chat. Go ahead, Phil. Go ahead and jump in.
Yeah, Kelly, Peter, first of all, thanks for putting all this together and letting people know about it. One thing I just wanted to mention in addition is that our Central Region Probabilistic Messaging Group, specifically Mike Fowl, Dan Baumgart, and myself, are putting together small 10-minute vignettes on how to apply these findings that Kelly and Peter shared with all of you into the messaging by providing specific examples. And those will be available, we hope, next week. We're recording them this week. We're going to review them and then have them available hopefully next week through the CLC. Or if there's a government shutdown, we may have to do it a little bit different way. But we are going to provide examples for you. We are going to provide templates that you can use or try and copy so that you can try and apply these results as easily as possible this upcoming winter.
All right, looks like we have a question, Paul, if you want to go ahead. We can't hear you, Paul. If you're trying to ask your question, might have an audio issue there. Any other questions? Anybody? I don't think I see any other hands raised currently, but if you have a question, go ahead and jump in.
Yeah, and Kelly, I did see that there were some comments there in the chat box. I'm trying to get through them here, but if there's a specific question with regards to that chat, just please raise your hand. We can answer it more broadly as well. Looks like Paul said, what if one office is doing 25 to 75 and the other is including static ranges? Great question. Kelly, you want me to handle that or?
Yeah, go for it.
Okay. So when the initial testbed happened back in the winter of 2020 and 2021, amongst the testbed offices, we actually had a dashboard that we were using amongst the offices where we would coordinate which one we were going to use. Depending on the situation, we had the ability to move between those. Did we show the legacy? Did we go to the more probabilistic 25-75? We also had the option of doing a 10th, 90th. And so we would have this dashboard, we would fill it out, not too dissimilar from what we might do when we're coordinating through AWEB's chat on a forecast change. But in that way, we could see what our neighbors were doing, and we tried to come to an agreement as to which one we were going to show, because you're right, if you have different offices showing different things, people will notice that, and it can cause some potential issues there, especially too if you end up doing more statewide maps that are served by multiple weather service offices. So that's why I was saying, when you talk about this idea of the messaging funnel or just messaging in general, you don't not only have to remain that consistency from forecast to forecast within your office, but you need to be constantly talking with your neighbors as well to make sure that they're on board and you're providing a unified message, whether that's through social media, a webinar, any kind of a decision support packet. And so it is a challenge, but it's something that I think needs to be considered. All right, is there anything else?
I see a question, somewhat a comment from La Crosse as well. maybe address that.
Kelly, can you see that? Sorry, I've got different screens up here. I'm trying to read it.
Yeah, so I think the question is, if we rephrase the questions and said for a 25th to 75% range, that half of the snowfall amounts would fall outside of the forecast range, would that change folks' perception of what is most valuable? Would they gravitate then more towards the 10th to 90th, knowing that there's less of a chance it would fall out of that? And that is what we were trying to do with the wording, the medium chance versus a 50% chance. But I do agree, you could ask it this way as well and see if that then again changes the respondents' perceptions. And if it did, we'd really have to dig into the why behind that.
Go ahead, Tony.
Thanks for the presentation, guys and gals. Real quick on the collaboration standpoint, with the school districts and whatnot, what we found, at least in Northern Arizona, is that when our county takes the lead on doing kind of snow preparation, like day of, they loop in the school districts as well. And so the communication between the county and the school districts is probably the best I've ever seen in Northern Arizona. And so that might go to the collaboration, building partnerships. That way they're getting the same message as the EM and the school districts in terms of canceling school and whatnot.
Yeah, that's a great point, Tony. And I'm sure this varies widely across the country in terms of what people are doing with the schools. I know that at least in Central Region, a lot of the offices are, so if you're not familiar, we have these decision support packets that we put out. And I know a lot of offices are not only emailing those packets to the emergency managers, but they're also sending it to their local superintendents. So they're getting the exact same information at the exact same time. And so, yeah, it's really helping to build that collaborative message and making sure that everybody's on the same page.
All right, last call for questions before we start our second talk with Keith. There's one in the chat from William.
Kelly, you want to take that one?
Yeah, future surveys. Yes. We do plan on fielding the survey again across Central Region. We do have rules we have to follow as far as if we expand this. We do have to go through, make sure it meets all the OMB rules. But definitely in the future, if other regions are interested in getting involved, that's certainly something we would happily collaborate on.
One last question from Mike Johnson. Is there a formalized introduction of the messaging funnel?
Phil, do you want to take a stab at that?
Yeah. Yes. There is training that we did initially in 2020 on the messaging funnel. It was a little bit different than the funnel that was presented here. It was based more on forecaster confidence. And then the training that Dan, Mike, and I are developing to be released hopefully next week kind of refines that messaging funnel technique to include the findings in the survey. So yes, there is training both out there currently. I believe you can find the messaging funnel on the CLC. A little like it's 15 minutes, I believe, and I can look that up if you're interested. Just send me an email. And the other training will be again 4 10-minute vignettes for you to follow to see how each stage of the funnel is addressed and how we apply the lessons.
All right, in the interest of time, I think that we'll wrap up our first talk. I'd like to thank Peter and Kelly for a great presentation. And if you have any other further questions, please reach out to them.